In the last video, we derived the general solution assuming a simple spring with no loss of energy. But it's not enough to just have the equations. We now need to interpret it and figure out how to apply it. In order to find a particular solution, we have to subject the differential equation to boundary conditions. Because there are two arbitrary constants, we need two of these boundary conditions. This can be done a few ways. We could specify the position at two different points in time, or we could specify the velocities at two different points in time. But typically we specify one position and one velocity at one point in time, almost always at t equals 0. We call these initial conditions. We will think generally. Say we want an initial position x0 and initial velocity v0. How would the solution look like? At t equals 0, our position must be x0. You can see here that all we are left with is just b1, and therefore b1 equals x0. Now take the derivative of the position function to get the velocity at every point in time. We require the velocity to be v0 at t equals 0. What we get is an algebraic equation containing b2. So now we have our particular solutions with the initial boundary conditions. Now let me graph the solutions and plug in some initial values. Omega equals 2, x0 equals 5, and v0 equals 0. Here, because we are starting with no initial velocity, the tangent at t equals 0 is perfectly horizontal. If we give the spring a really hard push at the start, x0 equals 4, v0 equals negative 5, you see that the graph has a negative slope at t equals 0. This pretty much concludes the simple spring. Everything we ever wanted to know about the behavior is given by the particular solution. However, let me give you a trick to rewrite our general solution with just one sinusoidal term. Here, a and delta are arbitrary constants, but solving for the initial boundary conditions is a bit trickier. I leave it up to you to figure it out using what we learned in this video. Regardless, I shall use this form from now on due to its compactness. I'm sorry to all my fans, but sadly Will Smith couldn't make it onto the show tonight. Apparently there was an incident. He just needed some space. Like I said, I really apologize. We really wanted him on board. But luckily we did manage to get our backup though. James Corden